Welcome back, guys. Today we'll be doing graphs and I'll be doing equation of a line where I'm talking about the gradient and y-intercept. First, let us look at some lines that we need to know. Y equal 2 and y equal -4 and x equal 3. What are the gradients for these lines? Now, y equal 2 is a horizontal line going through the y-axis at 2, while y equal -4 is a horizontal line going through -4. Both of them have a gradient of 0 since only the x values are changing while y is not changing. For x equal 3, however, what's happening is that for x equal 3, the gradient is undefined because the x is not changing, so you're going to have the y changing, having a number over 0. So a number over 0 is undefined. Now here we have the equation of a line y equal mx+c, where m represents the gradient of the line and c represents the constant, which is known as the y-intercept, where the graph cuts the y-axis. Now, here we have an example, y equal 2x plus 1. Now, the gradient is always whatever the number is in front of x, so the gradient is 2, and the intercept is 1. Now, when I say constant, it means the y-intercept. The y-intercept cuts the y-axis. So, in this example, I have y equal -2x plus 1. Now, -2 is my gradient and 1 is my y-intercept. When the gradient is positive, the line is increasing, and when the gradient is negative, the line is decreasing. So for this one, we have 3x minus 5y equal 2. So we need to determine what is the gradient and what is the y-intercept. So we have to rearrange. So I'm going to carry the 3x over the equal sign, so it becomes -3x, and the 2 is just positive 2. Now the standard form, I need to get rid of the 5, the -5 in front of y, so we divide the entire equation by -5. Now the -5 cancels, so we're left with y equal, now negative and negative is positive, so it's 3 over 5 x, and then here we have positive times negative, so it will change the sign. So just write that positive times a -2 over 5, so it means this will change to -2/5. So it means the gradient here is 3 over 5, and the y-intercept, which is the constant, the one without the variable, is -2 over 5. Now let's look at another example where we need to write it in the standard form y equal mx+c. So we carry over the -5, so it becomes positive. So I have 3y equal 9x plus 5. Now dividing both sides by 3, because the standard form there is no number in front of y. So dividing all of what we have here by 3. So the 3 cancels, so we're left with just y, and then 9 divided by 3, that gives us 3, and then rewrite the x plus 5 over 3. So it means that our gradient is 3 because the gradient is in front of the x, that's a coefficient, and the constant is considered to be the y-intercept, which is 5 over 3, and that is it. Now, let's look at this example where we're given two sets of points, A, which is 3, 6, and B, which is negative 1, 7. We can formulate the equation of a line, but first we have to find the gradient, and the gradient is equal to y2 minus y1 over x2 minus x1. Now, we are going to assign each number in the coordinates. So there's a pair that we're seeing. So we assign 3 to be x1, 6 to be y1, negative 1 to be x2, and 7 to be y2. Now let's substitute into the equation for the gradient. So y2 is 7, take away y1, which is 6, all over x2, which is negative 1, minus 3. So 7 minus 6, that's 1 over negative 4. So given the gradient, we can now substitute into the equation y equal mx plus c, where we're now finding out what exactly is the y-intercept. So we are going to now substitute any one of these coordinates, and I've decided to use b. So replacing y to be 7 and m, which is 1 over negative 4. Then replacing x with negative 1. So I'll have 1 over negative a quarter times negative 1 plus c. Negative times negative will give us a positive. So what we have now is 7 equal positive a quarter plus c. So we now carry this quarter over the equal sign, so the sign changed. So we have 7 minus a quarter equals c. So c is equal to 6 and 3 over 4. Get the y-intercept and the gradient. We're not through. We need to rewrite it in the formula y equal mx plus c. So as you can see, I'm replacing the gradient, which is negative a quarter for m, and the y-intercept, which is 6 and 3/4, and that is it. Now, the next example, we are going to find the equation of the line. Just a reminder, we have to find the gradient. So this is the gradient formula. And after finding the gradient, we can go about finding the y-intercept. Now, we have to label each point. So we have x1, y1, x2, y2. Then we're going to substitute this into the gradient formula. So we have 7, which is y2, and y1, which is 4. In the denominator, we have 2, and x1 is negative 2. So 7 minus 4 is 3, and 2 minus minus 2 is positive 4. Now we have the gradient. We can go about finding the y-intercept. Just a reminder of the equation of the line, y equal mx plus c. So we can use any one of the coordinates. Since I've used b in the previous example, I'll use a coordinates. So y is 4, the gradient is 3/4, and x is negative 2, and we're finding the constant. So we have 4, and then simplifying what we have here, 2 can go into 4 to give you 2. So canceling 2 into 4 gives me 2. So it's negative 3 over 2 because the negative sign multiplied by 3 over 2. Now carrying over the negative 3 over 2, we have positive, so it's 4 plus 3 over 2 is equal to the y-intercept So C is equal to 4 plus 3 over 2, which is 5.5. Now we're going to substitute into the equation. So the equation of the line is y equal the gradient, which is 3 over 4. Rewrite the x, and the y-intercept is 5.5. And this is the equation of the line. Now, just a reminder that when we have parallel gradient, the gradients are equal, while for perpendicular, when we multiply, we'll get -1. This example is asking us to find the equation of the line that is perpendicular to this line, 2x minus y equal 4, and it goes to the point 2 and 9. Now, what this is basically saying is that we have a line which is 2x minus y equal 4. This is what's going to help us to get the gradient of this line. We have to do some rearrangement, and the gradient of this line will assist us in finding the gradient of the perpendicular line, because we know that when we multiply the two gradients, it should give me -1. So it means the perpendicular gradient is -1 over the gradient that we're going to find now. Now the points, we're going to use it to assist us to find the actual equation, but before we can do so, we have to determine what's the gradient. So let us now find the gradient. We have to do some rearrangement of the equation of the line, 2x minus y equal 4, getting it in the form y equal mx plus c. Now, having the equation 2x minus y equal 4, writing in standard form, I'll carry the positive 4 over the equal sign, so it becomes negative, so it becomes -4, and carrying over the negative y over the equal sign, so it becomes positive y. So just rewriting it, I have y equal 2x minus 4. That's the equation of the line that's perpendicular to the one that I'm finding. And the gradient here is the coefficient of x is 2. Now it means the second gradient, which is the perpendicular gradient, is -1 over the original. So the original is 2. That's what the M1 means. So when I multiply 2 times -1/2, it should give me -1. Now having the gradient, I can now find the y-intercept given the point 2 and 9. So substituting the values that I have here, we have y is 9, and we also have m is -1/2, and we have x, which is 2. And the constant is what we're really finding. So we say 2 times 1/2, that cancels. So I have 9 is equal to -1, because the 2 cancels, plus c. Then we carry over the -1, so it becomes positive. So we have 9 plus 1 equal c. So c is equal to 10. Now once you have the intercept, you have to write it. So the gradient is -1/2, so you have the x, and the constant is 10. So the equation of the line is y equals -1/2 x plus 10. Now the next example, we have the equation, find the equation of the line that passes through the point 2, 3 and is parallel to the line. Now we have to rearrange this. This will give us the gradient, and for parallel lines, the gradients are the same. So rewriting it, we have 4x minus 2y equal 8. I am going to rearrange so that we have it in the form y equal mx+c. So I'm carrying the 4x over the equal sign and writing it first. So we have -4x plus 8. However, we have a negative 2 that's in front of the y, so we need to divide both sides by negative 2 to get rid of the number that's in front of y. Now, these two cancel, so we just are left with y. And negative 4 divided by negative 2, that's positive 2. Right, rewrite the x. And then here we have 8 divided by negative 2, that's negative 4. So we have the gradient of the line is 2. So it means the gradient of the line that's parallel to this line is also 2. So using this information along with the point we have 2, 3, we are going to create the equation of the line that's parallel to it. So calling the next one M2, we're going to write the equation of the line y equal mx plus c, and we're now going to substitute the information. So y using the 3, 2 is 3, and gradient is 2, x is 2 plus c. So we have 3 equal 2 times 2, that gives us 4, plus c. Then we carry over the 4 over the equal sign. So we arrive at negative 4. So it's 3 take away 4 equals c. So what that means is that our y-intercept is a negative 1. After finding your y-intercept, you need to rewrite it in the form, which is the equation of the line, y equal 2x, because the gradient is 2, minus 1, where minus 1 represents a y-intercept. Now, this example, we're asked to find the equation of the line that passes through 2 and negative 3 and is parallel to the gradient 2. We already know the gradient is 2, so since it's parallel, m1 equal m2, I can now equate it m2 to be also 2. Using the points that's given, 2 and negative 3, I'm going to find the equation of the line that's parallel. Now, replacing y with negative 3, and the gradient is 2, and x is positive 2 plus c. So writing the negative 3, we have negative 3 there, then it's equal to 2 times 2, that gives us 4. Then we'll have plus c. Now remember, we're trying to find the y-intercept. So we carry the positive 4 over the equal sign, so we have negative 4 and equals c. So it means the y-intercept is negative 7. And don't forget that once you have the y-intercept, we rewrite it as y equal the gradient, which is 2, and then rewrite the variable, which is x, minus 7. That's it. Now here we have an example where we need to find the equation of the line that passes through the point 1 and negative 5. The gradient is 3 for the line AB, but since it's perpendicular, we have to say the gradient of the second line is negative 1/3. Because when you multiply, you should get negative 1. We're asked to find the equation of the line. Once it's perpendicular, we have to use a perpendicular gradient, and the points that are given, which is negative 1 and 5. So y is 5, the gradient is negative 1/3, and here we have x to be negative 1 plus c. Now rewriting the 5, then multiply negative times negative, that's positive 1/3 plus c. Now carry the 1/3 over the equal sign, so we have 5 minus 1/3 equal c. 5 minus 1/3, that means c is equal to 4 and 2 over 3. Now once you have the constant, we are going to rewrite this, so it's y equal negative 1/3, and rewrite the variable, which is x, plus 4 and 2 over 3. And that is it. Hope you like this video, guys. Don't forget to like and subscribe.